Welcome to a discussion of Digital Advanced Laser Polarimeters and Optical Activity. My name is Gary Yannick, email gwyannik@pdr-separations.com. Introduction. Welcome to a new era of optical activity measurement. I personally developed the first useful laser polarimeters, began shipping in 1998, and still continue aggressive R&D. Did you know the internal calibrates of all PDR laser polarimeters introduce real optical rotations? I strive to develop micrometers for optical activity measurements, not just detectors. Now measurements are more sensitive and more accurate thanks to digital processing that reduces noise while compensating for eluents and flow cells. For more than 25 years, PDR laser polarimeters have been the best and now are much better with digital processing and a companion Dalp app delivering improved sensitivity with easy and accurate calibration and optimization. Dalp Digital Processing. PDR spent more than 10 years perfecting a new digital processing system and a companion Dalp app to improve accuracy, sensitivity, and convenience of optical activity measurements. Laser noise is eliminated. Automatic compensation for eluent and flow cell. Add and automate easily with any system. Upgrade old Alps for about $10,000 to have performance and features of a new Dalp. Here is the Dalp app. User settings include smoothing, gain, flow cell compensation, auto null options, calibrate peak width, and auto null delay. The password protected administration mode includes calibration and optimization with a precision shim, no chemical analytes, software upgrades, and diagnostics. Dalp shim calibration and optimization. Here is an analyzer prism in our patented flexure mount. Notice a stainless steel ball pushes against a carbide pin to rotate the analyzer prism. Inserting a precision shim introduces a precise and reproducible rotation for calibration and optimization. No chemical analytes are required. So what is a polarimeter? A polarimeter measures the optical rotation of polarized light passing through an optically active sample solution. Here is a polarimeter cartoon. We start with unpolarized light passing through a polarizing prism, resulting in highly polarized light passing through a sample solution. Now, if that sample solution has optical activity, it will rotate the plane of polarization of the polarized light. And that is what a polarimeter measures. Most organic compounds are optically active. Optically active compounds include chiral compounds, amino acids, antibiotics and pesticides, sugars and polysaccharides, proteins and peptides, polymers, vitamins and nutraceuticals, natural products, and flavors, smells, and essential oils. Now, the industries that use optically active compounds include chemical, pharmaceutical, biotech, biomedical, vitamin nutraceutical, food and beverage, and cosmetic industries. The significance of chirality. Chiral compounds are important in chemistry and biology. A molecule is chiral if it cannot be superimposed onto its mirror image by any combination of rotations and translations. Your left hand is not superimposable onto your right hand. They are distinguishable. Chiral molecules often exist as mirror images called enantiomers. Enantiomers have the same chemical properties, except when reacting with other chiral compounds. Life is based on chiral compounds and reacts differently to each enantiomer, sometimes violently. Dalp versus circular dichroism. Only polarimeter or circular dichroism detectors are sensitive to optical activity, not UV, mass spec, refractive index, fluorescence, etc. CD requires excitation within the absorbance band of a chromophore coupled to a chiral center. A stop flow scan may be required to set the excitation wavelength, not particularly convenient in a method screening station. CD polarity can change with excitation wavelength if the optical rotary dispersion plot has a zero crossing. I will show that in the next slide. The linear dynamic range is naturally limited in a CD because as the absorbance is increasing, the photon flux is reducing and the noises increase. CD is affected by absorbance-related interferences, including gradients. PDR laser polarimeters accurately measure optical activity directly with phase, not amplitude. Large rotations do not reduce Dalp photon flux or increase noises, so linear dynamic range is huge. Here is an optical rotary dispersion plot of a typical compound showing specific rotation versus wavelength. Notice there's a considerable change with wavelength, including a zero crossing until above 500 nanometers when plots go flat. Dalp uses 635 nanometer lasers where response is very stable and not affected by absorbances or wavelength variations. Some would suggest from an ORD plot that shorter wavelengths have more signal, so should be better, but shorter wavelengths have more noise and many absorbance interferences. Only signal-to-noise ratio matters. Linear amplification is easy. Digital Advanced Laser Polarimeter. What is it? Here is a cartoon. Laser diode, polarizing prism, Faraday rotator, flow cell, analyzing prism, photodiode, all digitally controlled and processed using our proprietary algorithms. Noises rejected, Dalp app for settings, calibration, and optimization, easy addition to any system, fully automatic, microdegree sensitivity, and microliter volumes. Dalp characteristics: universal optical activity detection, best sensitivity, largest linear dynamic range, no chromophore required, consistent plus-minus assignment, not affected by absorbance, no eluent limitations, broad applicability, easy addition to any flowing system, gradients, high pressure, high flow, etc. All okay. Scale from analytical to preparative to process with a complete family of flow cells. Full support for applications, calculations, automation, etc. Shipping since 2021. Dalp specifications: sensitivity, microdegrees in microliters, wavelength 635 nanometers, output 200,000 microdegrees per volt. Mean time between failure 10 years at 24/7, 365, including the laser. Power 100 to 240 volts AC, less than 20 watts wall plug power. Size 10 inches wide, 5.5 inches high, 16 inches deep. Weighs 22 pounds. Certifications include CE, UL, CSA, TUV, etc. Dalp applications: analytical, purification, process. Accurately detect optical activity with consistent polarity and linearity, regardless of elution order, solvent, or chromophores. Confirm enantiomeric separation and define the elution order. Control collections in purification. Measure specific rotation and enantiomeric excess. Deconvolve overlapping enantiomers. Monitor optical activity during reactions and conversions. Monitor protein and peptide conformation. Common Dalp applications: in HPLC SFC for analysis, method development, and purification, especially in labs supporting medicinal chemistry. Countercurrent and centrifugal partition chromatography purifications, simulated moving bed and multi-column chromatography optimization and purification, QC for sugar and sucralose products, antibiotic and pesticide herbicide analysis and purification, and optically active compound research at life science labs. Here is a typical chiral separation chromatogram. First appears a -100 microdegree calibrate peak. Next appears a +1000 microdegree calibrate peak. Notice it's before the void volume. The first eluting enantiomer in this case is negative. The second eluting enantiomer in this case is positive. This confirms chiral separation and defines the elution order. Changing columns can change elution order. Here's a chromatogram of transtylbene oxide on SS Welco column using hexane IPA 95.5. Here is a similar chromatogram using the same transtylbene oxide on a Chirocell ODH, also using hexane IPA 95.5. So notice they have the same analyte, the same eluent, but their elution orders are opposite. So here is a case where you can change elution order and add elution order to method optimization. Here is an ALP HPLC chromatogram of labetalol, a diastereomer with 4 enantiomers. So the minus 100 microdegree calibrate and the plus 1000 microdegree calibrate again appear before the void volume. Then there are a smaller pair and a larger pair of enantiomers, which are, of course, the diastereomer pairs. Each plus-minus pair of enantiomers exhibit a different specific rotation, so are distinguishable. Here is a chromatogram of gentamicin, an antibiotic. The analogs are separated along with impurities and cisomycin. Antibiotics often lack a UV chromophore, so UV detection is often useless. Here's a chromatogram of 4 sugars. Sugars usually have large specific rotations, so sensitivity is excellent. Sugars often lack a UV chromophore, so again, UV detection is often useless. Manufacturers of artificial sweeteners use Dalps for quality control and process monitoring. Here's an example of autoprep with ALP peak collection in SFC. Slope, amplitude, and polarity are used to detect peaks and select the proper collection port. This collection scheme does not require time windows and does not depend on elution order, resulting in easy setup and robust collection. Flow is routed to the correct collection port regardless of peak elution order or elution time. At the end here, notice that the collection valves move correctly at the beginning and end of the actual peaks, even though the peaks are getting smaller at the end of this bottle. ALP ignores chromophores. Years ago, ALP was used in a study of tetracycline treatment in milk cows, asking how many days after treatment before the milk is okay. This simple reverse phase HPLC method only required milk samples be acidified and filtered. So first appears the plus 1000 microdegree calibrate peak. Next elutes a huge protein peak, followed by 5 tetracycline analogs. ALP ignores chromophores and clearly shows the optically active tetracycline analogs as well as the protein. Again, UV was not useful because there were too many chromophores. Dalp can usually monitor real-time net optical activity during reactions with only filtering and no separation. Dalp summary: easy addition to any system at any scale. Universal optical detection of optical activity. No chromophore required. Consistent plus-minus assignment regardless of eluent. Best sensitivity, microdegrees in microliters. Largest linear dynamic range. No eluent limitations. Robust, 10 years mean time between failure at 24/7, 365, including the laser. Full support, applications, calculations, automation, etc. Let's discuss your situation to improve automation, performance, and productivity. Remember my email, gwyanik@pdr-separations.com. Thank you for listening.